Well, sure, but we would have to like do it like maybe in my office or something, like so they couldn't tell that it was coming through the thing, because otherwise, I mean, this person's smart enough to know the time period, or maybe they worked with campus safety like at 10 o'clock at night. It's like, oh, I just need to get in here to put a test under the door of my professor. Googly eye duct tape thing, whatever that monster was. But along the lines of the copycat thing, I kind of want to get involved now, but do something on a bigger scale. You know, like something on his car. I mean, not damaging his car, but just get giant googly eyes and like put it all over on his car or his house or his bedroom. This seems like what? Or I could text his wife, we get her in on it. Just one giant googly eye, like the shower or something. Something super creepy. All right, got this up. Did I start the recording? Yep. Okay, well, now that's recorded. This is where master plan. All right, so for today we had a homework assignment that we started on Monday, gave you some extra time to do it. Let's take a look at doing this. So the first part of this is create a graph data structure. So based on some of the questions that I had regarding this, it actually feels like it's kind of related to some of the struggles folks had on the midterm exam, where they constantly wanted to reinvent the wheel. They wanted to say, actually, it maybe goes the other direction. On the midterm exam, I was asking questions about like linked lists or stacks and said, assume you have these things. And then a lot of you didn't want to use the things that I gave you, just wanted to kind of reinvent it. Well, in this, folks were wondering, well, do we have everything we need to do this? So we want to remember that we're programmers. And if there's a tool that we think we need, sometimes we might have to create that tool. So we ask ourselves, well, what is a graph? So the first thing here is create a graph data structure. Well, a graph is going to be a collection of nodes, right? And it's nodes that are linked to other nodes. So a graph doesn't necessarily have a limited, a node doesn't have a limited number of children. And we don't have the idea of a child not being able to link back to a parent or something else. So it's kind of a free-for-all. But whatever we're thinking about here, we have, if I draw a picture, we will have a this is kind of Port Washington. This is Grafton. This is Saukville. This is Mequon. What else was on our map? We have Cedarburg. Oh, we got Fredonia and Belgium on there too. This is Cedarburg. Fredonia and Belgium. Oh, I can't do that to all of them at once. That's a shame. I should be able to resize them at once. Doesn't matter. All right, so this is effectively what our map will look like, where we'll have edges going from this guy to this guy, this guy to this guy, this guy to this guy. So let's go ahead and draw our edges in. That's Fredonia. That's Belgium. Saukville. Washington. Cedarburg, and really Cedarburg's gonna kind of be like there. This is Grafton, and that's Mequon. No. So then we'll go ahead and add some edges here. So there's going to be an edge connecting Belgium and Port Washington. There'll be an edge connecting Fredonia and Saukville. There's an edge that will connect Belgium and Fredonia. Port Washington and Saukville. Port Washington and Grafton. Grafton and Saukville, even though that's not really the way the roads go. Kind of Port Washington's more out over here, Saukville's here, but this is still representative. Grafton and Cedarburg. Grafton and Mequon. And Mequon and Cedarburg. Ish. Let's call that an ish. All right. So that's roughly what our graph needs to look like. That's what we need to construct. All right. Then we need to come up with the distances here. So it doesn't really matter what we put. So I'm just going to make up ish numbers. So let's say we have 6 miles between Fredonia and Belgium. And let's say we have 5 miles Saukville. Eight miles Port Washington to Belgium. We can always update these to be more accurate later on. Grafton to Saukville. We're going to say that this is 8 miles. Grafton to Port, we're going to say is 7 miles. Grafton to Cedarburg, we're going to say is 4 miles. Grafton to Mequon, let's say is 10 miles. I think it's less than that, but so Grafton's exit 93. What is Mequon's exit? 89, 7, maybe 85. I think this might be 8 miles. Let's just go with 10 for our example. And Mequon to Cedarburg, let's say 8. All right, so that's effectively the thing we're trying to build. Okay, so these guys are nodes. These guys are edges. So now when I look at a node here, the payload of a node is a string, the name of the town, right? So if we start planning this out, what are we going to need to build? I'm going to build a node that has a string payload. Well, we'll call it string town name. And then it's going to have a collection of edges leading out from that town. Could be one edge, could be 20 edges if we're in a highly populated area with zillions of towns all over the place. All right, we'll talk about what this collection might be here in a second. right. So that's what a node is. That's one of these blue boxes. Now, what's an edge? An edge holds two endpoints, a node and a node. So we can call this node N1, node N2, because an edge has a connection between two nodes in our current example. Okay. We could invent a data structure that goes a little deeper with this. Let's see if this chat is anything related. Okay. So an edge is going to connect two nodes. We could always invent a data structure that maybe has, we kind of redefine maybe the idea of an edge, but I think this is pretty clear what we're dealing with now. We're thinking about it as a road that connects two towns. So an edge always connects exactly two nodes. And in our example, if you wanted to name your node a town, you could. They don't need to be called nodes. So we can even say this is a town. And we can say this is a road. And this is town T1. Town T2. Kind of a similar thing to what we did when we did the Towers of Hanoi. We just kind of renamed them to kind of be meaningful for what we're creating here. Keeping in mind that depending on what you're going to do with this, we're going to be building effectively a graph whose nodes hold strings and whose edges hold numbers to model this. A node holds a string, the edge holds a number. Okay, along with the connecting points, what they connect between. I'm going to call them towns and roads here because that's what we're representing, but this is still a generic graph. I could rename those things to whatever, or I can keep them very generic and call them nodes and edges because it is a graph, but we'll give meaning to it here. So a road is going to have a town T1, town T2, and then it's going to have an int distance. We can make the assumption that the distances will always be whole numbers instead of 3.7 miles or something like that. I think that's fair enough for our current example. All right. So these are the constructs that we need to build here. All right. Let's go back to this idea of a collection of edges. How many edges will a town have? A single town will have how many edges? Go ahead. Yeah, who knows? Presumably there's one edge that there's some way of getting there, although there is a town in Alaska where the only way to get there is by boat. So there would not be a road for that one. That guy would have zero edges. He's just floating around out there. The cruise ships go there and it's a very boring place. I wouldn't recommend it, but apparently it's worth $500 to go watch whales. Of course, I read about that. I didn't actually experience it. I think there was a, what are the giant ice chunks called? A glacier. We paid money to go see the glacier too. That's where the whales were. It's a 2-for-1 deal. All right, so a town has a collection of, we could say 0 or more edges, but we don't know how many edges we're going to have. So when you think about collections of things, what are some of our options? We're going to collect a bunch of edges, collect something of similar data types. What are my options? In programming, what's built into the language for collections of things? Yeah, could use an array. An array is a collection of things, right? Okay. Now, we could say that, okay, well, here, let me ask you this. Is an array an appropriate data structure for this? Okay, tell me why. Okay, so an array, when we build it, we have to say, this is how many elements this array is capable of holding, right? Okay, where he just told us, we don't know how many things this is going to connect to. All right, so this is why we might say arrays are relatively memory inefficient, okay, but they are fast. And one of the things we referenced coming into this problem was this idea of the traveling salesman problem, which is slow. So the more fast things we can put in, that might be beneficial to us. All right, so it was somewhat of a loaded question when I said, would an array be an appropriate collection type for us here? I think the answer is yes, it would be, but it would come with some consequences, right? Because we could look at a map like this and say, you know what, if I think about an individual town and I just kind of imagine what are the most number of towns that a town connects to? Could we maybe say 10? Would that be horrifically unfair? We could always tune it later on if we needed to twist it, but could we just arbitrarily, I mean, certainly in our map, the most we have is, well, I see a 3. Port Washington connects to 3 places. Grafton connects to 4 places. So I think in our example, 4 is the most we would need. So certainly if we put a limit of 10, that wouldn't hurt anything, right? I think somebody had sent me a message about, well, can we, could we use C++'s data type called a vector? You could if you wanted to. It's still a collection type. A vector is to C++ as an array list is in Java, where it's still based on contiguous memory, but it allows you to change the size of it. So that kind of gives us our, but I promise you under the hood, it's destroying stuff. It just happens to be a convenience. So it's still memory inefficient. It just lets you let it grow or shrink. All right, so we could use an array and just set its max size to 10, for example, and then maybe have each town keep track of number of edges. So we know how far into that array we're currently using. That wouldn't be a horrifically unfair solution, right? Would be okay. What would be another possible collection type that we might consider for a town's collection of edges? Have we talked about any other data structures in this class? Go ahead. Linked list. Linked list. What's the advantage of a linked list over an array? Hold any number of things. So it could let us support the 0 or more towns this guy might connect to, right? Okay. What's the downside though of a linked list? So it's memory efficient, but relative to an array, what is it? Slower. Okay, so we kind of have a toss up here, right? We're making a decision, okay, as I'm building this, as I'm going to go ahead and I'm going to build my, I'm going to build my town, and I have my collection of roads coming out of that town. I can say, well, I'm just going to have an array of roads, or I can have a linked list of roads. Now, if I want to build a linked list of roads, I probably need to go back and maybe I can modify one of my existing linked lists to support a payload type of road. I could certainly consider the built-in data type called vectors, which we haven't worked with, but it's effectively has the usability of a linked list where we could just keep adding stuff to it, but it's built on top of the idea of an array. Or we could just say, look, I'm going to store not a gigantic number of roads here. I'm just going to store this as an array because I already have access to that guy, and I'll just keep track of how many roads I have. Seem reasonable enough? We could say an array of roads, and then an int number of roads. We'll just say in array for us right here. Okay. And at the very least, we could say, you know what, I'm being a little memory inefficient here. But this is not an inappropriate solution based on what I'm trying to do here, especially since we're kind of angling towards a problem that maybe some extra speed could be beneficial. And maybe memory isn't the biggest problem in the world. Although with Dijkstra's algorithm, memory could become a problem, but we'll burn that bridge when we get to it. All right. But we're going to be dealing with a small enough set where I promise we won't run out of memory and it won't take a month for the program to run because we're dealing with Ozaukee County and only a couple of towns. All right. So let's go build our data structures here for these guys. We'll build objects for a road and an object for a town. Where am I going? Sure this guy is saved. We'll create a new project. Save this guy as CSC300. I'll just put TSP, traveling salesman problem, on it for right now. All right, then we'll go ahead and create a new file. And we're going to go ahead and call this guy, what I call it, town. So we'll have town HPP. So inside of town HPP, we're going to implement this guy. We're going to have a string town name and an array of roads. So let's go ahead and create our roads HPP as well. Okay. Now inside of my town HPP, I'm going to include road HPP. I'll also include string.h, right? Because we're going to have to work with strings here. We're going to have a class called town. All right, so oh, that's not how we save it here. That's how we save it here. All right, so going back to this, what's a town? It's going to be a string town name. So we'll have string town name. And these are going to be our private section. And then we're going to have an array of roads. So I'll have a road pointer collection of roads like this. And then we're going to keep track of the number of roads in the array. Int number of roads in collection. All right, then we're going to have our public section. And inside here, we're going to go ahead and implement our constructor. So we'll have our thing called town. And town's going to take in a string town name. It's also going to take in, actually, I think that's all it's going to take in when we first build a town. When a town first comes into existence, it has a name and it has the capability of holding some roads, but we haven't built the roads yet. Fair enough? Okay. We'll go ahead and add some stuff to this in a few minutes, but we're going to have things like add edge, stuff like that. But for right now, let's just leave it as generic as possible. Okay. And then we're going to go into road. What is our road? Oh, Seems like a road is going to need to have access to town. And then it's going to have a distance variable. So we're going to include town.hpp. We're going to have a class called town. We'll have our public section here. This guy's going to have town T1, town T2, and a distance. So we're going to have a town pointer T1, a town pointer T2, and int distance. Oh, hold on. I'm building road here, right? Class road has access to town. Town pointer T1, town pointer T2 has a distance. And this is our private section. Then our public section will have a constructor for road. And when we first build a road, we're going to need the two towns that it's going to connect, as well as the distance. Town pointer T1, town pointer T2, int distance, like that. Go ahead and save this. All right, so let's go ahead and let's implement our town CPP. We're going to set this town name equal to town name. Now, remember, a town also has a collection of roads, and it also has a number of roads in the collection. So we need to go ahead and initialize those things. So we'll say this number of that guy. We'll start that off at 0. Now we need to go ahead and we need to give ourselves enough memory inside of collection of roads to hold on to, like we said, maybe a number of some maximum number of roads. So maybe we go into our town HPP and we decide that we can go ahead and give ourselves a global variable here, called max towns, or sorry, max roads. So maybe say int. Actually, we can do it this way. We can say define max roads to be 10. This guy's called a macro. I think that's a syntax for macro. That. Oh, hashtag define. But just give me a quick example. I think I pretty much remember. Define max roads to be equal to 10. You don't put an equal sign. Effectively, what you're saying is whenever I have this showing up in my code down below, 10 is a value in it. Nothing would have kept us from just calling this an int max roads equal to 10. Just wanted to show you one new thing here. All right, so I'm going to steal this and we'll bring it over here to town CPP. So now what I need to do is I need to ask the operating system for enough memory to potentially hold max roads number of roads. So we'll say this, call it collection of roads is equal to, this guy is going to give us a road pointer. We'll call Malloc, and what we want is max roads times size of a town pointer. So this is going to give us an array. This gives us enough memory to hold this many of these guys. So in our example here, 10 town pointers. All right. Plot of land. I don't have towns there yet, but I have the potential to hold some towns. Actually, it's not town pointers, it's road pointers, right? A town as it's a collection of roads that lead from a town. So this is not a town pointer, it's a road pointer. All right. So that's what our constructor for town will do, is it'll initialize these things. And right now we have 0 roads, but we have enough space to hold up to max roads number of roads. Now road CPP. We'll include road HPP. To implement our constructor. This T1 is equal to T1. This T2 is equal to T2. This distance is equal to distance. Okay, that's our constructor for road initially. All right, we might need to do an if not defined type thing in here, since town relies on road and road relies on town, but we'll see if the preprocessor on this requires that. We will know shortly. So now let's go ahead and let's just build our towns, or collection of towns here. Well, let's build one town first. So we're going to include town.hpp. We'll include IOStream if we want to print some stuff out using namespace standard. And we're going to create a town pointer. Grafton is equal to a new town. And when we build a town, what do we pass it? We pass it just the town name as a string. So there's Grafton. All right. So let's go ahead and run this and make sure we clean up any compile issues for maybe. Yeah, this is our infinite loop because town and roads are reliant on each other. So let's see. I think what I can do here in town is I can say if not already defined, include, actually, hold on, this isn't the wrong one. I could just leave it out of here to make the problem go away. But just to show you what we can do here is inside of town HPP, I can say, if I don't already have access to road, implement road. Let's see if that fixed up that problem. Okay, now it's complaining about our strings, because I think that uses namespace standard, right? I think you need both namespace standard as well as string in order to use strings. No macro name if and def. Just spell it wrong. Because I'm trying to include in there, I have to use it with define. Okay. Oh, I need to tell it if it's not already defined road HPP. All right. Yeah. Oh, why am I making this so much more difficult? Let's just make sure this fixes it before I spend more time on this. Town HPP. Let's figure out the string issue first. Oh, string is not my, double quotes around it. And then it's just include string. Okay, so that fixed up string. So now we need to go back to our town thing. So a town does need to know about roads. Oh, I actually need to put it in here. Let me get back to my previous error. This should be the infinite loop one. And the reason we get the infinite loop one is they're reliant on each other. So really, so a town relies on a road relies on a town. So let me just get the right. Okay, got it. So these guys will include both. So what we'll say here is, if not defined, town HPP so we're only going to define this if it wasn't already defined. And we're going to do the same thing in road. These guys only get redefined if they're not already defined. Make sure that I am. Give me a good example. So I get the syntax right the first time. Otherwise, we'll have to do it a different way. All right, so these are all just warnings. Do not need to put that in front of it. I'm sure you do. If not defined. This is what we have as codependent classes. I'm almost positive it's if not defined. The pragma thing looks like it would do it. The alternative is you could put them in the same file. feel like this is something that their C++ compiler is preventing, but the not defined. I know we have 1 minute left, so regardless, I'll get it fixed up. But the next thing we're going to do in here, once I have these two dependencies fixed up, is we'll go ahead and create instances of all of our towns. And once we have instances of all of our towns, then I can create instances of the edges between those towns and add them to each town. So this town will get this edge. Well, this edge will be born with Fredonia, Belgium, and 6. And then I'll add this edge to Fredonia. I'll also add that edge to Belgium. So after I build all the towns, I'll build all the edges in terms of those towns, and then I'll add the appropriate edges to the towns. That's our graph. Graph is done then. Have to find some way of displaying it all to prove that you built the graph, but that's it. Just having these two objects and then making sure you create edges in terms of them. Don't create a new version of Fredonia for each of these two edges. You have Fredonia exists once, this edge has a pointer to it, and this edge has a pointer to it, because that town exists one time, right? Create our towns, create our edges in terms of those towns, add the edges to the right towns. Okay, I'll spend a few minutes here and figure out how this guy wants the thing up top saying that, you know, if one's dependent on another, how to make sure it doesn't get redefined over and over and over again inside of here. It'll be pretty close to what I have, but I'll get it figured out and give you a link to the code. We'll come back on Monday and finish this up and then go on to the next step. Sound good? Questions, comments, concerns, bribes? All right, I will see everybody on Monday. You too, Griffin.